Here's a supplement for the one prop Z test mini project. Number 1. A report from the U.S. Consumer Product Safety Commission claimed that at least 90% of all American homes have at least one smoke detector. The city's fire department has been running a public safety campaign for smoke detectors consisting of posters, billboards, and ads on the radio and TV and the newspaper. The city wonders if this concerted effort has raised the local level above 90% national rate. Building inspectors visit 400 randomly selected homes, find that 376 have smoke detectors. Is this strong evidence that the local rate is higher than the national rate? We're going to use a significance level of 0.05, and if ever a significance level is not given, we just assume it's 0.05. So let's go ahead and state HO and HA in symbols. So HO is going to be, we're going to make sure you can choose the right symbol. So HO would be P, the proportion, population proportion, equals 0.9. So the HO is always equals every single time. Make sure that the symbol you use is always, it's in this class, it's going to either be a P for proportion or it'll be a mu for mean. Now, if you go into more advanced statistics classes, they will often use pi for the population proportion. Students that are just getting into statistics, though, that kind of confuses them because we've known pi for so long, it's ingrained that it's 3.14159 as the ratio of a circle's circumference and diameter. So we often kind of soften a little bit by just using p. So similarly, HA. So what are they expecting this to happen? They're expecting and hoping that it's going to show that the rate is greater than 0.9 or 90%. Now, you can put 90% here. We often know in statistics classes, we'll frame these as proportions since this is a piece for proportion. Now, this will add-on question. Is there evidence for HA? I mean, do we even need to run a test? For instance, if we took a sample and found that 80%, well, there's no need to run a statistical test to see if it's greater than 90%. We know it's not. So is there evidence for HA? Well, yes. So P hat is 376 over 400, and that's 0.94, which is greater than 0.9. And I believe on the mini projects, I just have you choose one of the choices, and that's kind of what I'm looking for. And I probably did that because getting P hat there is not super easy. Are the conditions met? We sort of assume that they're met. I might even have said that up here. Independent assumption that they were independently selected. They just didn't go to one apartment complex in one part of town and get everybody there. So random sample, random assignment. Our sample can't be too large. So if the city only had 600 people there, we can't really use this due to independence. Usually not a problem at all. And the large count condition. This is one that sometimes can be a problem, particularly when our value here, the parameter, is pretty close to 1 or pretty close to 0. This is actually pretty close to 1, so it's healthy to go ahead and run that out. Is n times p bigger than 10? And n times 1 minus p bigger than 10? They are in both cases, so we are good there. Now let's run the test in StatCrunch. Okay, so we're going to go to stat. This is a proportion, so we're going to go to proportion stats and one sample. So in this class, we're pretty much going to go, when we're running a hypothesis test, we only have 2 parameters we're looking at. We're going to be looking at proportions. We're going to go to proportion stats. We'll either have 1 or 2 samples, or we'll go to means, which is the t-stat, and it'll be 1 or 2 sample, or they actually have a paired option here. So we have proportions. So proportions, 1 sample, and we have summary data. Okay, so the number of successes. 376 had a smoke alarm out of a total of what? 400. And we are testing this to 0.9. And then make sure you change HA. If I forget to do something, this is probably it. So change that to 0.9. I like going ahead and popping a p-value plot on here just so I can look at it. Okay, so here we go. So here is our output. And this is what you would copy and paste if I asked for it. Here's our p-value plot. And it looks like when I went back, I didn't do it right. So it's t-stat. I chose z-stat. We should get something pretty close. Maybe this is instructive. Summary. Let's do that again. Okay, cut that last part out. Okay, so what is our test statistic? Our test statistic is z equals 2.67. How about the p-value? 0.0038. That's a pretty small p-value. Okay, so what are we going to do? Small p-values mean the likelihood of us getting a result, 0.94, if the true proportion really is 0.9, is very unlikely. Only about 4 out of every 1,000 samples. So we're going to reject that. Very unlikely. 4 out of 1,000. So what are we going to say our conclusion is? So since the p-value is less than alpha, we're going to reject HO. Conclude that there is enough evidence that in this city, more than 90% of homes have smoke detectors. And that's kind of what my gut was going to tell me. I'm going to take away that enumeration. There we go. When I saw 0.94 with that large of a sample, it's pretty unlikely to get that by chance. Now, if I only had like 10, and let's say I had 20, and I had 19 out of 20, that'd be 95%. But that's a pretty small sample size. So I could get at another sample, and it's likely that it would not have gotten that high. Okay, part G. Often when we do reject HO, we have a follow-up question, right? So if we just say it's more than 90%, the natural question, right, is, well, what is it? If we just had one number, we would say it's around 94%. But we can do better than that. We can actually create a confidence interval, which is pretty easy to do in StatCrunch. I'm just going to go and edit my test and change this to confidence interval. And we'll just make it 95%. And here we go. We're at 0.92 to 0.96. So we are 95% confident that between 91.7 and 96.3% of the homes have smoke detectors. Or we can say we're 95% confident that the true proportion of or percent of smoke detectors is between 91.7 and 96.3%. Okay, number 2, last one. Rock, paper, scissors, also called Rochambeau, is a popular 2-player game often used to quickly determine a winner and a loser. In the game, each player puts out a fist for rock, flat hand for paper, and a hand with 2 fingers extended scissors. In the game, rock, paper, scissors, rock beats scissors, which beats paper, which beats rock. The question is, are the 3 options selected equally often? Knowing the relative frequencies with which the options are selected would give a player a significant advantage. A study of 119 people playing rock, paper, scissors. Here are their choices for their first turn. So it looks like rock. I'm just looking at it. It looks like rock is significantly higher than paper or even scissors. So do the data provide evidence the proportion of times players start with rock is different from the 1/3 we would expect if the players were choosing randomly? Use a significance level of 0.05. Let P be the proportion of times players uses rock on the first turn. Okay, so let's state HO and HA just on the same line here. So HO always equals. P equals 1/3. HA, now you would think it would be P is greater than, because it looks like the proportion is greater than 1/3. However, as mentioned in the video, summary video, or in class, that we always choose this before we actually run the data. So we're just going to say not equal to 1/3. We don't have a sense of the direction. Again, since in a textbooky type problem, they have to give you everything all at once, so we actually already know it's greater than, but we actually have to set this up before we even collect the data. So do we have evidence to support this? Well, yeah. Our p hat is 66/119, which is about 0.555, so we do have evidence that it is not 1/3. Our conditions are met, and that large count condition is the only one I really want to check, is 1/3 times 119 bigger than 10, and is 1 minus 1/3 times 119 bigger than 10, and they check out. So now let's run the test. So I'm going to go to stat, proportion stat, 1 sample, and we just have summary data. And we're testing the rock proportion, so 66/119, to 1/3. And I believe we can just put 1/3 in like that. If not, you can put 0.333. Press compute. There we go. So here's our test statistic at 5.12, so we're 5 standard deviations away from the mean. Very unlikely to have occurred by chance. Super small p-value, less than 0.0001. Okay, so what do we do now? Do we reject or fail to reject? Super small p-value, very unlikely to occur by chance, so we're going to reject HO. Now let's state the conclusion in context. So since the p-value is really low, we're going to reject HO and conclude that there is strong evidence the rock is used more often than random chance would suggest on the first turn of rock, paper, scissors. All right, so I hope that helps.